Okay, in 4.3, what we're going to do is we're going to look at different expressions and put those on a graph so we can see either graph or chart to see if they're equal or not, or when they're equal. Okay, so what we're doing is we're using tables and graphs to solve an equation. So let's say that we have this equation. If we have 2x plus 3 equals 7x minus 4, okay? We want to figure out what is x here. That's what we're looking for. So what we can do is we can set this portion, this half, into an equation of a line. Okay, so I set that into an equation of a line. And I set the other one into an equation of a line by just plotting y equals 7x minus 4. And if you notice, the y's are going to be the same because we want y to equal 2x plus 3. We also want y to equal 7x minus 4. So this is one way of doing it. I'll just tell you right now, this is probably the longest way to do it is to do it by tables, okay? But I want to show you how you can do it. Now, I threw those up there. I don't know what kind of answer we're going to get, but we'll at least look at the table, okay? So basically what you're doing is you're going to put in values for x. We're going to call this 2x plus 3. This y is going to be 7x minus 4. So you're making a table with values of x. We're putting into both expressions, and we're trying to find where the two y's equal each other, because that would be the x that makes it true.
That could take so long.
Yeah, that's why I'm saying this is not our best way of doing it, okay? But it gives you the idea. So I could put in, let's put in negative 3 just to see what we get. So 2 times negative 3 is negative 6, plus 3 is negative 3. Does everybody agree with me there? Okay.
Yeah.
Negative 3 times 7 is negative 21, minus 4 is negative 25. Whoa, they are way apart at this point, okay? They are way apart, okay? So let's try 0. If I put 0 in, 2x times 0, or 2 times 0 is 0, plus 3 is 3. 7 times 0 is 0, minus, so we're getting closer now. We're at 3 and negative 4. We're at least not quite so far apart, okay? So
Let's try 3.
Well, let's try 1. If I put 1 in, I get 2 plus 3, which is 5. If I put 1 in here, I get 7 minus 4, which is 3. Do you notice, oh, these numbers are still above those numbers, okay? This looks like it was closer, well, okay. If I think the farther I go from this, so right now, 3 to negative 4 is a difference. Oh, this is only a difference of 2. So let's try 2. What is 2 going to give us? It's going to give 2 times 2, which is 4, plus 3 is 7. Here it's going to give 2 times 2 is 14, minus 4 is 10. Okay. We're starting to go apart again. So I'm going to guess that the answer is somewhere between 1 and 2. Okay. Hard to see, right? Tables aren't very useful. Now, if they gave you a table and they asked when they're equal, that would be a whole lot easier, okay? So if they gave you a table, you could see when they're equal. So let's just say that, okay, they gave you this table for x, and we're going to have this one be 2x plus 3. I'm not going to give that exact one.
Or I put down 1.5. and I got 6 and 6.5.
So we're very close, yes, so it's gonna be in that area, yes. And you can keep narrowing it till you get an answer like that, okay? I know it's gonna be between 1 and 2, so yes, we could try numbers in between those. But to get the exact answer might be really hard because this is probably a fractional equation because I made it up. It's always what happens, right? Okay,
Not
so we're
always.
gonna use this one as okay. So now, if I gave you that this is true, I'm gonna give you these three. 1, that's gonna be 2 plus 3, which is 5. 1 here is gonna be 7. 2 here is gonna be 4 plus 3, which is 7. 2 here is gonna be 8. 3 here is gonna be 6 plus 3 is 9. 3 plus 6 is 9. Looky right here. They are equal when x is 3. See that? So our solution here would be x equals 3, because when these are the same, that's when x is 3. So 2x plus 3 equals x plus 6. X equals 3 is the solution to that without doing any math. Okay, so that's what we can say. We can see on the graph that they're both the same when x is 3. So the solution here, and you can plug it back in and check it. So that's using a table. Tables are like the worst thing unless they give you exact numbers.
Are we gonna have to do this on the board?
We might.
Which you can bring.
So the next thing we can do, and this is actually easier, I want you to use Desmos. So I'm going to show you the answer to this one I just had, which now I can't remember it. Y equals 2x plus 3, and y equals, was it 7x minus 4? Yeah. How many wrote it down?
Yes.
Okay. So if we go to Desmos, and I'm hoping everybody knows how to do Desmos, you want to go to the graphing calculator. I'm going to show you this so you guys can come see. Okay, so on the graphing calculator, you plug in the equations. Okay, so y equals 2x plus 3. Oh, that's a capital X. Okay. X plus 3. Okay, it drew the line for us. Okay, Grayson, Ed, can you see it?
Yeah.
Okay, so then you go down to the next one. You just hit enter. And it takes you to another one. It's going to print it blue because now we have a blue color there. So it's going to say y equals 7x minus 3. Okay, so if you look at those, now we have the two different ones graphed. Okay, where are they the same? Well, they're the same where they cross. So if I go to look, so we're going to see how close Med was. We're going to go look up here. So it shows, oh, okay.
What? Of course I was wrong because I didn't get it.
It's 1.2 when they are identical. X is 1.2. Now again, I told you it was going to be between 1 and 2, right? I could see that. I didn't know how much, but 1.2 isn't far off from 1.5. You were still a little off, okay?
3 decimals.
Yeah, but that's still off, okay? But the thing about a graph, you can actually find it by using Desmos, because if you graph the two equations, you will find where they intersect or where they're the same, okay? So if I were to graph, you can also graph tables in here. So let's say you had, I can't remember how to do a table right now.
You have to go to a different kind of spot. Yeah, down there.
2-point form. You could do it 2-point form. So you can just find the 2 points and connect them, and that will graph it. So if you have a graph, I could plot 1 and 5 and 3 and 9. Okay, for the first one, I could plot 1 and 5 and 3 and 9 and see that graph. Okay. Then I could plot 1 and 7, and we already know 3 and 9 connect, but 3 and 9, and you can see where they connect. So on a table, you can use what's called 2-point form. So there's slope-intercept form, which is what I used when I first started, and then there's point slope. Oops. Guess I'm leaving the page. No, I don't want to do that. You have to be smarter than me on these things too. I'll just say that. It's not even typing in right now. It's being a pain for me. Yeah. So play around with it. Learn how to put points. I also think you can go like this. 1/5. Oops.
You also, on the bottom left, there's like a keyboard thing and it shows up,
That's true too.
yeah.
Okay. Okay, but then I could say with the same, now we're going to keep it comma. I'm not sure if this is how we can do it. I'm checking. 3.9. Okay, that's not it. I have to see what the things are between it. Okay. Can't multiply point by a point.
I took your home.
I'm not even
I'm not sure how they do that in here to get the 2 lines. Control C. Control C doesn't work. Control C. Okay. Right, get rid of that. So now, where's the red dot? I don't see the red dot. It didn't give it to me. We could connect these two just by using your, but that's a lot harder. Just graph the point. So, and if you know the equation, just put the equations in, and we'll kind of look at that today. We'll do a few of those on there. So the other way, besides making a table, you can also graph it. We are using Desmos to graph it. And so if you have an equation like 3x plus 5 equals 2x minus 7, again, you can just make it y equals 3x plus 5. You can make it y equals 2x minus 7. Graph them on Desmos. And look for the point of intersection is what it's called. That's a funny word for just saying find the x value of where they cross. Oops. Because the x value where they cross will make this equation true. Okay, it will solve that equation. Okay, now right now, that's a lot of work to just solve an equation like this. Graphing is very easy if you're using Desmos. Be
It's
honest,
also really
that's
just-
very easy.
Just solve it.
Okay, yeah, but we're gonna go into solving that tomorrow. Okay, so we just want to show you, you can use graphs to solve something like this. You also can use tables to solve it if it's somewhat convenient, but if it's not a nice even number, it's not gonna work out very well. The graph will be much better, okay? So I always suggest if you don't know, plug it in and actually see what you get on Desmos. Okay, now it's time